The sound of metal footsteps echoes through a quiet suburban home at 6 a.m. But these aren't the steps of a human waking up early. A gleaming white humanoid figure moves gracefully down the hallway, carrying a freshly brewed cup of coffee to its owner who's still asleep. This isn't science fiction anymore. This is the Tesla Optimus robot Butler that Elon Musk promised would change everything about how we live. While the internet buzzes with claims of a $1,490 price tag, the reality behind Tesla's most ambitious project reveals a story far more complex and fascinating than any headline could capture. Subscribe now and hit that notification bell, because today we're diving deep into the truth behind Tesla's robot. Revolution that's about to reshape your daily life in ways you never imagined. Comment below. Would you trust a robot to handle your morning routine, or does the idea of artificial intelligence in your home still make you uncomfortable? The morning light filters through smart glass windows as the Optimus robot seamlessly integrates into what might soon become the most normal scene in American households. But behind this futuristic vision lies a technological marvel that represents the culmination of decades of research, billions of dollars in investment, and the relentless pursuit of artificial intelligence that can truly understand and interact with the human world. The technical specifications of Tesla's Optimus robot read like something from a science fiction novel. Yet every component has been engineered with the precision that made Tesla the world's most valuable automaker. Standing at 5 feet 8 inches tall and weighing approximately 125 pounds, the Optimus robot possesses a humanoid form factor designed specifically to navigate spaces built for humans. Its skeletal structure consists of lightweight, yet incredibly strong materials that Tesla has perfected through years of electric vehicle manufacturing. The robot's torso houses the most sophisticated computer system ever installed in a consumer robotics device, powered by Tesla's custom-designed AI chip that processes visual, auditory, and tactile information in real time. This computational powerhouse enables the robot to make split-second decisions about everything from how much pressure to apply when picking up a delicate wine glass to calculating the optimal path through a cluttered living room. The hands of Optimus represent perhaps the most impressive engineering achievement, featuring 11 degrees of freedom that allow for incredibly precise manipulation of objects, ranging from threading a needle to lifting heavy furniture. The robot's sensory capabilities extend far beyond simple cameras and microphones, incorporating a sophisticated array of sensors that create a three-dimensional understanding of its environment. 8 cameras positioned strategically around the robot's head and body provide 360-degree vision, while advanced depth sensors measure distances with millimeter precision. Tactile sensors embedded throughout the robot's hands and arms can detect texture, temperature, and pressure, allowing it to handle everything from fragile eggs to heavy packages with appropriate care. The audio processing system can distinguish between different voices in a crowded room, respond to whispered commands, and even detect emergencies through sound patterns like breaking glass or calls for help. Neural network processing occurs locally within the robot, ensuring that personal conversations and private information never leave your home, addressing one of the primary concerns about privacy in an increasingly connected world. Tesla's approach to robot intelligence differs fundamentally from traditional robotics companies that rely heavily on pre-programmed routines and limited artificial intelligence. Instead, Optimus leverages the same full self-driving technology that Tesla has been developing for its vehicle fleet, adapted and enhanced for the complexity of indoor human environments. The robot learns continuously from its interactions, building a personalized understanding of your preferences, routines, and needs. When you consistently take your coffee with 2 sugars and prefer your morning newspaper folded a specific way, Optimus remembers these details and incorporates them into its daily service routine. This learning capability extends to understanding the unique layout of your home, the locations of frequently used items, and even the behavioral patterns of pets and family members. The manufacturing process that makes a dramatically reduced price point possible represents a revolution in robotics production that leverages Tesla's automotive assembly expertise. Traditional humanoid robots are essentially hand-built in small quantities, with costs often exceeding $100,000 per unit due to specialized components and labor-intensive assembly processes. Tesla's approach applies the same mass production techniques that allowed the company to drive down electric vehicle costs while maintaining quality and performance. The Optimus robot shares numerous components with Tesla's automotive line, from batteries and electric motors to sensors and computing hardware. This part's commonality reduces manufacturing costs while ensuring reliability through components that have been tested in millions of Tesla vehicles worldwide. Automated assembly lines designed specifically for robot production can manufacture thousands of units per month, creating the economies of scale necessary to achieve consumer-friendly pricing. However, the journey from concept to consumer has been anything but smooth, and current industry reports suggest that the optimistic price projections may not reflect the immediate reality of robot ownership. Recent statements from Tesla CEO Elon Musk indicate that Optimus robots will likely cost between $20,000 to $30,000 when they reach mass production, a significant increase from earlier speculative pricing that captured public imagination. Manufacturing challenges have proven more complex than initially anticipated, with reports suggesting Tesla has only built a few hundred units by mid-2025, far short of the ambitious production targets that would enable dramatic price reductions. The integration of advanced AI capabilities with physical robotics requires quality control standards that exceed even Tesla's demanding automotive specifications, as a software glitch in a robot Butler could have far more serious consequences than a minor issue in a vehicle's infotainment system. The economic implications of widespread robot Butler adoption extend far beyond individual households, potentially reshaping entire sectors of the service economy in ways that economists and sociologists are only beginning to understand. Domestic service industries, from house cleaning and lawn care to elderly care and child supervision, face fundamental disruption as robot capabilities improve and costs decrease. A robot butler that can clean, cook, and provide basic care could replace multiple service providers, generating significant savings for households while potentially displacing millions of jobs. However, this technological shift also creates new opportunities in robot maintenance, programming, and customization services, suggesting a complex economic transition rather than simple job replacement. The luxury market implications alone represent a multi-billion-dollar opportunity that has captured the attention of investors and industry analysts worldwide. Wealthy households currently spending tens of thousands of dollars annually on domestic staff could achieve similar or superior service through a one-time robot purchase, fundamentally altering the dynamics of domestic labor. Property values in areas with robot-friendly infrastructure could see premiums similar to those currently associated with smart home technology, as homes equipped with robot charging stations, automated systems, and compatible layouts become more desirable. The insurance industry faces new challenges and opportunities, as policies must account for robot-related risks, from potential property damage to liability issues if a robot malfunctions while caring for children or elderly family members. Adoption patterns will likely mirror those seen with other revolutionary technologies, starting with early adopters willing to pay premium prices for cutting-edge capabilities before gradually expanding to mainstream markets as costs decrease and reliability improves. The initial customer base will probably consist of tech enthusiasts, high-income households with demanding schedules, and families with specific care needs that traditional services cannot adequately address. As social acceptance grows and word of mouth, testimonials demonstrate practical benefits, broader market penetration becomes possible, potentially reaching a tipping point where robot butlers become as common as smartphones or personal computers. The psychological and social implications of living with artificial intelligence companions represent uncharted territory for human society, raising questions about relationships, privacy, and the nature of domestic life itself. Children growing up with robot butlers will likely develop different expectations about work, service, and the role of technology in daily life compared to previous generations. Family dynamics may shift as robots take over routine household tasks, potentially freeing human family members to focus on relationships, creative pursuits, and personal development, or alternatively creating new forms of dependence on technological solutions for basic life skills. Tesla's Optimus robot demonstrates capabilities that seemed impossible just a few years ago, performing complex tasks that require the integration of visual processing, manual dexterity, and decision-making skills. Recent demonstrations show Optimus bringing packages inside, unloading groceries from cars, watering plants, and even playing board games with families, indicating a level of versatility that approaches human-level competence in domestic environments. The robot can navigate stairs, open doors, and manipulate objects of various sizes and weights, from delicate glassware to heavy furniture, adapting its approach based on real-time analysis of each situation. Cooking capabilities represent perhaps the most impressive application of the robot's advanced AI and manipulation systems, as preparing meals requires understanding recipes, managing multiple cooking processes simultaneously, and making subjective decisions about seasoning and presentation. The robot can learn family preferences, dietary restrictions, and cultural food traditions, gradually developing a personalized cooking style that reflects the household's tastes and nutritional needs. Safety systems prevent accidents by monitoring cooking temperature, detecting gas leaks or smoke, and ensuring proper food handling procedures that exceed restaurant industry standards. Home security integration transforms the robot butler into a sophisticated guardian that provides protection far beyond traditional alarm systems. The robot's continuous presence and advanced sensor capabilities enable real-time monitoring of all areas of the home, detecting unusual sounds, identifying unauthorized individuals, and responding appropriately to various emergency scenarios. Unlike static security cameras or motion detectors, the mobile robot can investigate disturbances, provide visual confirmation of threats, and even take protective actions, such as creating barriers or activating emergency protocols. Integration with local law enforcement and emergency services ensures rapid response to genuine emergencies while minimizing false alarms through intelligent threat assessment. Elderly care applications represent one of the most socially significant capabilities of robot butlers, addressing the growing crisis of aging populations and insufficient care resources in developed countries. The robot can monitor health indicators, remind elderly users to take medications, assist with mobility challenges, and provide companionship to reduce social isolation. Fall detection and emergency response capabilities provide peace of mind for families with elderly members living independently, while regular health monitoring can identify potential medical issues before they become serious problems. The robot's ability to learn individual patterns and preferences enables highly personalized care that adapts to changing needs over time. Child care capabilities, while currently limited for safety and regulatory reasons, hint at future applications that could revolutionize family life and childhood development. The robot can supervise play activities, assist with homework, and provide educational content tailored to individual learning styles and interests. Safety monitoring ensures children avoid dangerous situations while still allowing for age-appropriate independence and exploration. Language learning capabilities enable the robot to serve as a tutor for foreign languages, potentially giving children access to native-level instruction in multiple languages from an early age. The reality of Tesla's production timeline and market availability tells a more complex story than the optimistic projections that dominate social media discussions and technology blogs.